Circular and rotational motion. Chapter 7. Circular and rotational motion. Ponder this. On a carousel, does the speed of a horse change when it is further from the center of the carousel? On a carousel, where is the speed of the carousel the greatest? Close to the center. Midway between the center and the outside. Close to the outer horses. All move at the same speed. On angular displacement axis of rotation is the center of the disk. Need a fixed reference line, similar to a reference point in linear motion. Angular displacement, cont. The angular displacement is defined as the angle the object rotates through during some time interval. Linear and rotational analogues. Delta x, linear displacement, or s, arc length, in m. V, linear or tangential velocity, in meter per second. A, linear acceleration, in m/s2. Rotational. Delta theta, angular displacement, in radians. Omega, angular speed, in rad/s. Alpha, angular acceleration, in rad/s2. Analogies between linear and rotational motion. Conversions between angular and linear quantities. Displacements. Speeds. Accelerations. Every point on the rotating object has the same angular motion. Every point on the rotating object does not have the same linear motion. Centripetal acceleration. An object traveling in a circle, even though it moves with a constant speed, will have an acceleration. The centripetal acceleration is due to the change in the direction of the velocity. Centripetal acceleration, cont. Centripetal refers to center seeking. The direction of the velocity changes. The acceleration is directed toward the center of the circle of motion. Centripetal acceleration, final. The magnitude of the centripetal acceleration is given by. This direction is toward the center of the circle. Forces causing centripetal acceleration. Newton's second law says that the centripetal acceleration is accompanied by a force. Fc equals Mach. Fc stands for any force that keeps an object following a circular path. Tension in a string. Gravity. Force of friction. Centripetal force example. A ball of mass m is attached to a string. Its weight is supported by a frictionless table. The tension in the string causes the ball to move in a circle. Centripetal force general equation. If the force vanishes, the object will move in a straight line tangent to the circle of motion. Centripetal force is not a force in itself. Centripetal force is the net force on an object moving in circular motion, usually due to a combination of forces. Centripetal force cont. General equation. Note, centripetal force is not a specific classification of force, like friction or tension. Centripetal force is the net force on an object moving in circular motion, usually due to a combination of forces. When a car takes a curve at a constant speed, the centripetal force is due to frictional force, circular force, tensional force, gravitational force. When you swing a lasso above your head, the centripetal force is due to frictional force, circular force, tensional force, gravitational force. The centripetal force that causes the Moon to orbit the Earth is due to frictional force, circular force, tensional force, gravitational force. Comparison of all three types of circular motion. Angular motion, centripetal motion, tangential motion. Describes rotation directly using radians. Angular displacement. Theta rad. Angular velocity. Omega rad/s. Angular acceleration. Alpha rad/s2. describes what is happening rotationally with a snapshot of the tangent in normal units. Arc length sm. Tangential velocity Vermont meter per second. Tangential acceleration at m/s2. Acceleration toward the center of the circle that keeps an object moving in a circle parallel to the radius of the circle. Centripetal acceleration AC. Centripetal force FC. Angular motion. Tangential motion. Centripetal motion describes the angle of rotation around a circular path using radians, regardless of radial distance. Describes the motion of an object along a circular path in terms of meters traveled, depends on radial distance. Motion or forces that are directed toward the center of the circle, keep objects moving in circular paths. Rad. M. N. Rad/s. Meter per second. Rad/s2. M/s2. Theta. R. S. Gravity humor. Newton's law of universal gravitation. Gravitational force is directly proportional to the masses of the objects and inversely proportional to the distance between the objects. Effects of gravity. Ocean tides, due to the gravitational pull of the moon on large bodies of water. Orbiting objects are in free fall. Newton's law of universal gravitation. According to Newton, the amount of gravity between two objects is affected by both mass, m, and distance between the centers of the objects, r. G, determined by Henry Cavendish, not Newton. Newton's law of universal gravitation. G equals Newton's gravitational constant, 6.673 by 10 to 11 nm2/kg2. R equals distance between center of objects in meters. m1 and m2 equals mass of objects, kg. Field force. Gravitational force is a field force. The vectors show gravitational force vectors within Earth's gravitational field. If you fly from NYC, sea level, to Denver, your weight will, assuming you do not eat, drink, excrete, increase, decrease, stay the same. Unable to be determined. You travel to another planet that has twice the radius of Earth but is twice Earth's mass. Your weight on this planet compared to Earth is more, less, the same. Unable to be determined. Torque. Definition of torque. Torque is defined as the tendency to produce a change in rotational motion. Torque is determined by three factors: the magnitude of the applied force, the direction of the applied force, the location of the applied force. 20 N. Location of force. The forces nearer the end of the wrench have greater torques. 20 N. Magnitude of force. 40 N. The 40 Newton force produces twice the torque as does the 20 Newton force. Each of the 20 Newton forces has a different torque due to the direction of force. 20 N. Direction of force. Q. Units for torque. Torque is proportional to the magnitude of F and to the distance r from the axis. Thus, T equals Fr. T equals Fr. Units, Nm. 6 centimeters. 40 N. T equals 40 N 0.60 meters. Equals 24.0 Nm. T equals 24.0 Nm. Sign convention for torque. By convention, counterclockwise torques are positive and clockwise torques are negative. CCW. Positive torque, counterclockwise, out of page. CW. Negative torque, clockwise, into page. The moment arm. The moment arm, r, of a force is the perpendicular distance from the line of action of a force to the axis of rotation. 20n. Location of force. The forces nearer the end of the wrench have greater torques. Example 1. An 80 Newton force acts at the end of a 12 cm wrench as shown. Example 1. An 80 Newton force acts at the end of a 12 cm wrench as shown. Find the torque. Extend line of action, draw, calculate R. R equals 12 cm since 600 equals 10.4 cm. T equals 80 n 0.104 meters equals 8.31 Newton meters. Alternate, an 80 Newton force acts at the end of a 12 cm wrench as shown. Alternate, an 80 Newton force acts at the end of a 12 cm wrench as shown. Find the torque. Positive 12 centimeters. Resolve 80 Newton force into components as shown. Note from figure, Rx equals 0 and Y equals 12 centimeters. T equals 69.3 and 0.12 meters. T equals 8.31 Newton meters as before. Rotational equilibrium. If sigma tau equals 0, the system is in rotational equilibrium. Be sure to note the signs of each force. Counterclockwise equals positive, clockwise equals negative, when adding the torques.